If you just start to learn game development with a code-centric framework like libGDX, modern games and love duties, then making cursor effect is one of the best methods to explore the framework's API and animation techniques. Cursor effect is very fun to look at and very visual appealing, and if done correctly, it also enhances player experiences with the game. This is the first video of the series making cursor effects in Java and libGDX. There are 12 cursor effects we are going to implement, and today we are going to create this repo cursor effect. By the way, this video also has a written tutorial, so if you prefer reading the text, check out the link in the descriptions where you can read and download the projects as well. Alright, let's get started. The repo effect is one of the cleanest and most minimal cursor effects that creates immediate visual feedbacks when players interact with the game UI. It is inspired by a Google material design. The effect creates and animates multiple circles that are expanding and fading out from the center of the touch point. First off, let's use GDX libdop to generate our project. Enter a project name, package name, and the main class name, then click Next. Select the classic template here. Also select Core, Desktop, and HTML VM for the platforms. Now we don't want to use any extensions, so just ignore this page and click Next. On the screen, select libjava 11 here, which is the requirement for TVM, and pick a location, then click Generate. And we get the project ready. I'm going to make a shell script so I can execute a creator task for me to test the game on desktop. Here I'm switching on some Gradle properties to streamline my workflow a bit better. The first thing I'm going to do is to change the default window dimensions so we have a bigger canvas to work with. Now let's run the project to see what we got so far. To draw the repo, we can use any image editors like GIMP or Photoshop to create a wide circles on a transparent background. Alternatively, if you are comfortable with using the command lines, install image magic case and run the following command. Magic K with the size parameter set to 256 by 256, axis none to create a transparent background, fill white because we want a solid white circle. Now draw a circle with a center point at 128 by 128 and an outer edge position at 128 by 0. And finally save the output a repo.png. This will generate the exact white circles on a transparent background that we want. Now let's move this repo circle to the assets folder. Now open your IDE, check the assets folder and make sure that the repo sprite is already there. In the entry class, let's rename the default image to repo text and use our repo image instead. Now let's draw it to the screen at 0, position. I like to use a brighter colors for the background, so let's change that as well. Here you can just replace 0.15 by 0.8 for the red and green channel to create a lighter tone. The algorithm to animate the ripples is very simple. From the touch point, we start drawing a white circles with a minimum size, then gradually enlarge and expand it until reaching a maximum size where we stop rendering the circle. While expanding, we also reduce the circle opacity to create a graceful fading effect. The repo class is a Java inner class that abstracts the repo algorithm we just discussed. It has the following properties: two floats, center X and center Y to store the repo position, an opacity to store the repo current opacity values set to 1 by default, a size variable to store the repo current size. A boolean is completed to signal the end state of the instance. We can conveniently put the repo class right inside the entry class and make it implement the pullable interface because we want to use objects pool to manage our repo instances. A pullable interface needs a recess method, so let's add an empty recess method as well. Just leave it here and we'll come back to it later. Now we can create the pool objects to manage our repo instances. Pool equals to new pool, then implements the new objects method, which returns a new repo instance. In addition to the object pool, we also need to create an array to contain the current repo instances on the screen. This is effectively the render list for our application. By the way, if you want to learn more about object pool, check out the link on my website, which explains the object pool techniques in greater details. First of all, let's add two constants to define the repo maximum size and the easing factors used to animate the circles. Now the values for repo max size and repo easing can be arbitrary, and by changing the values, we can create many variations for our effect. Now let's come back to our repo class to initialize the properties that we have discussed before. Let's declare the center X, center Y, and size properties. Then the opacity field, which is set to 1 by default. And finally, the boolean is completed. Then we can add a render method inside the repo class to draw and animate the repo. Here we increase the size variable to reach repo max size and reduce the opacity simultaneously. To add easing animations when resizing, we use these formulas: repo max size minus size, multiply repo easing, multiply delta. You want to learn more about easing animations and how to apply them? Check out these articles, Quick Easing Motion Tips in libGDX. Now let's use sprite batch to draw the repo sprite to the screen. First set the opacity value with sprite batch set color method. Then draw the repo text sprite using the center X and center Y position with the size properties. The second and third parameters of the draw methods are the sprite location on the screen. We have to offset the X and Y positions with half of the size value to draw the sprite at its centers instead of the bottom left corner. The fourth and the fifth parameters are the sprite width and height. Remember to reset the batch color as well so it won't mess up with other entity colors. When the size value nearly matches repo max size, we switch the flash is completed to signals that the instance has completed its life cycle. And it will remove the repo instance from the current render list and return it to the pool. We use a placeStat method to conveniently set the repo initial position and size. Inside the method, just assign center X and center Y with the new values from user input. Also reset the size method as well. Pick a small inner value so the circle is at minimum size at the beginning. Remember the reset methods we have created before? Now we can fill its body with the default values for the repo properties. Alright, let's put everything together in our main render method. First, retrieve delta values using GDX, graphics, get delta time. Then, watching for user input. If there is a click on the screen, we generate a repo instance using our object pool. Place the instance at the exact same location of the click point. This should be repo, not repo text. We use repo placeStat method to assign the location of the mouse via GDX input get X and GDX input get Y. For the Y coordinate, you have to invert it because the input coordinate is top down, while the screen coordinate is bottom up. Don't forget to add the instance to the render list. Remove this line because we don't need it. If you run the code right now, it shows nothing because we haven't actually rendered any repo yet. So let's do that. First off, obtain the array size and iterate backward to retrieve its repo instance. The reason we have to iterate backward instead of forward is because we want to get the instance data and remove it from the array at the same time if it has finished its life cycle. If you iterate forward, it will mess up the array order. If you want to learn more about this technique, check out these articles, how to correctly remove array elements during iterations on my website. Call the render methods on each instance. Also check if the instance has completed its life cycle, so we can return it to the pool properly. This prevents memory leak and saves you a lot of trouble later on if you want to initialize like thousands of objects on the screen. And we are done. Let's run the code and test it. And it's working. It looks clean, simple, but really nice to me. It feels like touching on the water surface and the waves show up. As mentioned earlier, by changing the values of the constants, it's possible to create many variations for our ripple effect. Let's try changing the maximum size first and see what's happening. Do you notice that the circle radius is larger than before? We can also change the easing factors values. When you have the time, try to experiment with the constants and also the circle colors so you can create more variations of it. And that's it, we just finished the implementation of one of our cursor effects in our series. I hope you enjoyed the tutorial, see you next time.